My name is Sarune, and I'm here to present our research study investigating representation of text and audio in educational VR using learning outcomes in EEG. I'm here on behalf of myself and my colleagues, Aske, Mottelson, Terkildsen, and Guido Makransky. Altogether, we come from the University of Copenhagen in the Virtual Learning Lab. And at our lab, we do a lot of really cool and interesting things, all investigating learning in virtual reality. This study is specifically embedded in my PhD project, where I've been looking into how can we use knowledge from human cognition and psychology to design effective virtual reality applications for learning. So this study was motivated by surveying the existing virtual reality education tools and tools that students have available in the market today. And what we can see is that most educational virtual reality systems are heavily based on read-mediated written and spoken representation formats that are very customary to traditional 2D media and have been just ported into this immersive space in virtual reality, as you can see from this beautiful picture here. So there's a sort of a hidden expectation or implied expectation that these representation formats might be just as effective in immersive media as they are in two-dimensional media. However, we know very, very little about how do we actually cognize and make sense of these representation formats in this new immersive space. So with this motivation, this study was focused on investigating three main research questions. So the first one is reading or listening superior for learning in virtual reality. The second one, are embedded interfaces more superior for learning in virtual reality? And the third, are there any differences in cognitive processing when learning from different representations in VR? So there are different theoretical foundations that we used for designing our experiment. I don't have that much time to go in depth with all of them. However, just to give you an overview, the first school of thought that we looked at was the cognitivist kind of approach, in particular the cognitive load theory, the dual coding theory, or the modality principle, that say that presenting some information in the visual mode and other information in the auditory mode can reduce cognitive load and expand effective working memory capacity. We also looked into more the perceptual domain, for example, the Colavita visual dominance effect, that states that the phenomenon wherein visual stimulus, whenever shown at the same time with auditory or other stimuli, have a tendency to dominate consciousness. We also explore more new and novel approaches in cognition and cognitive studies, such as embodied cognition and embodied learning, where the assumptions would be that the contextual embeddedness, bodily cues, and physical interactions can affect higher level cognitive processing, like learning and metacognition. So our study at the end consisted of three different conditions: the overlay condition, the virtual book condition, and the auditory condition. So in the overlay condition, the idea was that students learned from this overlay modal interface that was static to the environment with text represented on it. In the virtual book condition, the students learn by reading text presented in a more embedded, contextually embedded format. A virtual book was exactly the same representation of text as in the overlay condition. However, this time it was only mapped on a different object in the virtual world that was actually embedded in the virtual world. They were able to rotate the book around, but the representation of text and the way that they interacted with it didn't change at all. Same with the auditory condition. It was exactly the same text that the students listened to there. However, this time, the text was not written, but it was spoken by a voice actor and pre-recorded prior to the experience. The playback was the same. Nothing in the environment, characters, the participant's position, the space, or anything like that didn't change throughout the experience. So it is only the format of representing information that changed. So we developed a specialized virtual VR application for this in Unity and optimized it for the HTC Vive system. So the task was to read or to listen to these 25 different snippets presented in these different representation formats. Each snippet had a unique information point that students had to learn on the topic of sarcoma cancer. Sarcoma cancer was chosen due to its novelty for the general population, And there were 78 university students that participated in the study in between subject design. As you can see, these are examples from how the procedure looked out in our lab. The experiment was seated, so students didn't have to move around, and they interacted with the content only by pressing a button on the HTC Vive controller, which the only thing that the button did was allow them to move through the sequence of pre-recorded and predefined sequence of these snippets that they were learning from, and they were not able to go back. So there were different measures that we used for evaluating efficacy of these different representations. And for the learning outcomes, we investigated retention, transfer, and self-efficacy. And the retention measure, we investigated how well did the students retain information from the different snippets. In the transfer measure, we evaluated how much they could synthesize all the knowledge presented to them and apply it to a novel learning context. In self-efficacy, they were asked to rate how confident do they feel with their learning. For the second set of measures were cognitive load measures. Here we evaluated mental effort, concentration, intrinsic load, meaning how difficult did they perceive the content to be, extraneous load, meaning how difficult did they perceive the format the content was represented to be in. And these were all Likert scales. Then we had a visual attention measure that evaluated how much extraneous attention did the participants pay to the objects and the environment surrounding it. And finally, we had an EEG, our EEG measures, where we focused on the EEG frequency domain, especially in the theta and alpha frequency bands. So the results. So for learning outcomes, we saw a significant difference in retention, but not in transfer. A significant difference was between the audio and the book condition and the audio and the overlay condition, which basically suggested that when information was displayed in an auditory format, the participants were able to form an overall understanding, but could not remember the details implicit in the learning content. We saw a significant difference in the self-efficacy measure, where students perceived the book condition to be significantly higher than the audio condition, and there was almost a significant difference between the book and the overlay. For cognitive load measures, we saw significant differences in intrinsic and extrinsic cognitive load. In intrinsic cognitive load, the content was perceived to be the most difficult in the auditory condition and the least difficult in the book condition. For extrinsic cognitive load, the format of representation was perceived to be the least difficult in the book condition and the most difficult in the overlay condition. For visual attention, in the auditory condition, students paid the most attention to the extraneous environment and remembered most details from the environment. Theta activity was lowest in the audio condition, and low theta activity in the auditory modality might indicate lack of memory retrieval and sensory integration. And since we know that auditory information is more transient, this might suggest that there is an impede of passing of information from short-term memory to long-term memory. From the alpha results, we saw high alphas in the audio condition and lowest alphas in the book condition. So high alpha activity in the spoken condition might indicate lower levels of sustained attention and cognitive effort. And since they also retained less in the auditory condition, low alphas might indicate overall lower levels of engagement when learning. Low alpha activities in the book condition, on the other hand, indicate higher mental activity, which might suggest that engagement on motoric action might stimulate cognitive processing. So our conclusions, very quickly, from learning efficacy, if we had to summarize which representation is the best, we saw that embedded text outperformed both of the conditions, and auditory representation formats were performing the worst in terms of learning efficacy. So we ended up our paper with presenting some design recommendations for using text and audio in educational VR. These are important factual information should be presented as text, not audio. Text should be contextually presented in the environment. Learning information could be presented in audio if attention to the environment is required or if memory workloads should be minimized. Learning information could be presented in audio if remembering facts is not the goal of virtual reality. another important kind of conclusion that we wanted to draw from this paper is suggested by the superiority of embedded representation formats, which suggests that learner's body, the space, and the learning context might have significant implications for learning in virtual reality, which says that we should try to use the affordances of virtual reality as much as possible when we're designing educational content for learning in VR. So thank you. I hope you enjoyed the presentation. Here's our contact information if you guys want to contact us and ask any questions. Unfortunately, I probably will not be able to make the presentation today, but I hope that Aske will be able to answer all your questions. If not, just drop me an email, or otherwise just drop me an email, and that's great.